Okay, so now that we know our logic gates, we should try solving a problem. This case, we'll just start with the pictorial problem or a picture, and we're going to use three inputs, A, B, and C. Okay, these inputs can either be on or off, and they will lead into our logic gates. So we're going to draw these wires are going to lead into an AND gate, and then we'll have an OR gate over here, and then we're going to do a XOR gate at the end. Alright, so looks like we're missing one input for the OR gate right here. So we're going to have to borrow one of the A or B's as our second input into this XOR gate. Well, to do this, we're going to have to cross over the B line if we choose A. So I'm going to show you that if you just draw a dot, that means that the two lines are connecting. Some people, they will draw a line straight through the other lines, but generally the best practice is to draw a C over line to show that the lines are not crossing each other. So just draw a C over line if you ever have to cross them. And then we'll draw our output from the OR and our output from the AND going into our XOR gate, and then we label the output. Okay. Well, now that we have this picture drawn, we need to figure out all the possible combinations of inputs that create outputs. Most people will just draw a truth table. Now, truth tables, they show you every possible combinations, but the word truth kind of makes sense because 1 represents true, 0 represents false. So, truth table, we will just put all of our variables up here, A, B, and C. And if you ever done something like this in math, it'll make quite a bit of sense to you. We will also include the AND and OR gate that we have here. So this is usually written as A and B. So we're going to do A with the asterisk B, and then we're going to have A plus C for our OR gate. And then we do our output. Okay? And I'm just going to draw these lines down. A or B, A and B, A or C, and that's the table that we need. Now, for this, we just write every possible combination of A, B, and C we have. If you guys ever been done probability, this would be pretty simple to write out. So A can be, we're going to be 0 or 1. So in this case, I'll draw 4 ones and then 4 zeros. Now I'm doing that because the B can be 0 or 1 as well, and the C can be 0 as 1. So I'm just doing this to keep organized. So the B will do 2 ones, then 2 zeros, then 2 ones, then 2 zeros. And then C, we're just going to be crazy, and we're going to alternate 1, 0, 1, 0, 1, 0, 1, 0. And you'll find out that this is every possible combination of values that we can have for each of the variables. And this turns out to be a number of 8. Now, if you ever want to find the maximum number of combinations you have with logic gates, you will just do the number of inputs you have. In this case, we have 30, and you raise 2 to the power of your inputs. 2 to the power of 3 is 8. So, if we have all of our inputs, if we have A and B on, A and B is going to give us a 1. A and B on, it's going to give us a 1. And not both A and B are on, so we'll get a 0, a 0, 0, 0, 0, 0. You see, both A and B have to be on to give us a 1 on A and B. Now A or C, we have to have either A or C on. So we need to look for the place where A and C are both off, which is right here, and this one right here. So we'll just put zeros here, and then the rest of them will be ones because we have one in A or B for the rest of the values. 2, 3, 4. That's not quite written the way I want it to be, so I'm just going to rewrite that. Okay, so the last input is this XOR gate. So we'll take our A and B or XOR our A or C. Okay, so since this is XOR gate, we have to do either one or the other. So if they're both on, your output's going to be a 0. If one of them's on, your output's going to be a 1. And if none of them are on, then your output's going to be 0 again. So you're going to get 0 at the bottom since none of them are on. And A or B, one of them's on, you get a 1 here. Neither one of them are on, you get a 0 there. One of them's on, 1 on, 1 on, 1 on. And you have just completed your first truth table. Now, when we get into problems that ask you what will the output be for one condition, you can just look at the truth table. So if we say A and B are true or 1, and C is 0 or false, okay? Then the question will ask, what is the output or something like that. We're just going to exclude that because we're running out of room. So A and B are 1, C is 0. We can just look for when A and B are 1 and C is 0. So it'll be this condition, and then we just go over here and you see that the output should be 0. We just messed up our truth table there because both of these are on. The output should be 0 on a XOR gate. So the output equals 0, and we can just box that in.